Okay, so if triangle ABC is congruent to triangle DEF, there are only three possible transformations it could be. Translation, rotation, and reflection.
Wait,
okay.
Mr.
Yes.
Okay, so you know how dilation and reduction are the opposites of each other?
Yeah, but remember, the book just calls everything dilation.
No, yeah, but then what would be the difference between a translation and a slide?
They're the same thing.
Then
slide is just another name for translation.
Oh, okay. Thank you.
So now keep in mind when you're doing your test, it's not going to show the word slide. It's going to say translation. So that's why whenever you guys, if you say just slide, I'll say translation back to you, or I'll always say translation or a slide, because it's important that you guys know that they're the same thing. If you want to call it a slide, that's fine. I just need you to remember in the back of your head that that's a translation. Okay. So these three, that's horrible. These three are rigid motions, meaning it doesn't change size. It has to be a rigid motion because they're the same exact shape, right? If I had my triangle, I'm sorry, Alexa, I apologize. I don't want to switch between my tools today. If I have these two triangles and I slid one over to the other, I didn't change size. They're the exact same shape. If I reflected it, I didn't change sides. I just flipped it upside down, and so on and so forth. If I were to do a dilation, I would end up with a bigger triangle or a smaller triangle. And that's not the same shape. It's not congruent. The sides are going to be smaller. Remember that a congruent triangle or any congruent shapes, all of the sides and angles are equal to each other. Okay. Yes? Kaylee, we now understand why it has to be a rigid motion?
No, yeah, it's just I forgot what the problem was asking. So then I was like, oh wait, why am I right? But then I got it. Thank you.
Yes. Okay. Now the next one, number 6. So here's my pre-image. Here's my image. Now, which transformations are applied to figure A to obtain figure B? So what transformations? Type them in the chat. Let me know. Pia is correct.
Wait, but I'm confused.
Why?
Oh, okay. But wait, how come? Oh,
Wait.
oh, okay. No.
I feel like the day that Kaylee doesn't say she's confused, it's like the end of the world.
Yeah.
Or do we figure it out on our own, Kaylee, or we have to ask the question?
No, because here's the thing. Pia makes sense, obviously. But okay, you know how like if you reflected over y equals whatever line, you know, okay, but like if you were to do that,
No.
how would you do it? I'm saying that's the question. How would
It wouldn't work. It wouldn't work in this case, and I'll explain it afterwards.
No,
Elena,
but
you're
how
right
would
as
it
well.
look is what I'm trying to say.
How would it look?
Yeah, if you did that, because I can't, my brain isn't working. So,
I'm not gonna do it right now. I'll do it after the problem
okay, thank you.
because I want to make sure that we understand and I'm not drawing all over this. So wait, a few more answers. very quiet today. All right. So, yes, Jordan. Wait. You know what? Yeah, I'll accept it. Okay, so this one, the picture looks different than how I drew it, so I can see how there are different answers. The main two are a reflection and a translation. So if I reflected it across the Y, it would have been somewhere around here. Sorry, Alex, I'm sorry. I know she's dying on the inside while I draw these triangles freehand. So reflect it somewhere over there, and then I would have to move it down and to the right a little bit, okay? So that would be one way. Now, I do like that I had, what is it? So let's say this is 1, this is 2. So if I had reflected it over this new line of x equals 2.
So where did this come from? Quick question.
Hold on. Haha, I like that one. So it's still a reflection and then a slide. It's just a reflection over a different line and then a translation down 4. What was your question, Kaylee?
Okay, so remember how yesterday okay. No, stop. Not this class too. Okay. Okay, so basically,
Focus.
I'm trying. I don't know how to ask the question. You know how when you said that if we were to draw the line, why the diagonal one, right? And then it would reflect diagonally, you know? How would it look?
So if I did this one diagonally,
Yeah.
it would look like this. Not curvy, obviously not curvy. It's curving because I can't draw triangles. Do we see how that's not what I was looking for?
Wait, but did it go diagonally?
Yes, this is the reflection across the diagonal. It might be a little bit off, but that's the general what it looks like.
Oh.
Do you see why it doesn't work when I do the diagonal?
Yeah, I get how it doesn't work. It's just when you would do it diagonally, wouldn't the base be at the side instead? Because it's diagonal.
Well, like I said, I might have done the sides wrong,
But it still wouldn't work. Okay,
but it still wouldn't work.
yeah.
Okay.
Okay.
But I do like, that's the first time I see that answer, that reflection over the x equals 2. I like that because it's true. It doesn't matter. I could have flipped it over the 2 and it actually makes it a little bit more exact than a reflection over the y and then having to move it to the right and then having to move it down. So remember that this question isn't so specific, right? On your test, it's not that specific. It's literally, are you reflecting it and then a translation? Are you rotating it and then a translation? So the main point is that we understand that it had to be flipped by a reflection and then slid around, okay? So that's good. All right, Next one, number 7. Carisha drew pentagon A. Don't criticize me for my pentagon. It's not a good job. On a coordinate grid, she then performed a rotation followed by a dilation with a scale factor of 5. To produce pentagon B. Now there's no drawing for pentagon B. There's not even a drawing for pentagon A in the actual assignment. Yes, Jordan, you are right. But which statement is true of the 2 pentagons? So the thing you have to think about is the translations being applied. So go ahead and put in the chat what you think the answer is, and then I will explain it after a couple minutes. Yes, Elena, you are right too. So think about it. It's a rotation and a dilation. Kathy, you're right as well. See, this test isn't going to be so bad. All right, so we all seem to be, almost all of us seem to be picking the correct answer of C. So we didn't really talk about similar, we only talked about congruent, and congruent is when they are the exact same. So once you see a dilation, A is not an option, D is not an option, okay? Now you're just between B and C, okay? So the next thing is to think of, well, are they going to be similar? So similar is, right, they're kind of the same, but maybe not the same size, maybe something is off. So if I had, let's say the pentagon ended up being bigger, right? The fun thing about similar shapes is that most of the time their angles are all the same. I have too many little lines. You guys get the point. So my angles, just because my shape grew bigger, my angles don't necessarily all the time get bigger as well. So that leaves me with, they are similar, but not congruent. So whenever you see a dilation, you should think to yourself, okay, not congruent, but similar. It's always going to be that. If they're not congruent, well, if there's a dilation, they're not congruent, then they'd be similar. Okay, so that answer is C. Yes?
Wait, how come when the shape gets bigger, the angle measure doesn't change?
Okay, if I had a square, if I had a box, right? A square is 90 degrees on all the angles, right? Yes?
Yes, sorry, I'm muted. Yeah.
If I have a small box, a small square, all 90-degree angles, and I make it 10 times bigger, aren't my angles still going to be 90 degrees?
Maybe.
It wouldn't be a square if they weren't. True or not true?
True.
So that's why the angles don't actually get bigger. The sides do, right? The sides are the ones that get bigger. And I don't know if you guys know it. I don't know when it's taught, but we should have maybe heard side, angle, side, 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 side. There's one called angle, angle, angle. And angle, angle, angle is only for similar shapes, right? If all the angles are the same, it proves that they're similar, but not necessarily congruent. They could be, but you don't use angle, angle, angle to compare, to determine if the shapes are congruent. Okay, number 8. So the coordinate plane below shows the location of triangle A prime, B prime, C prime. So this is after the transformations. This is my image. Okay. My original triangle, ABC, was shifted 5 units to the left and 3 units up. Okay, so it says point D prime, grab that prime there, point D prime is on that triangle. So which of the following describes the transformation? So basically, okay, so there's many points on this triangle, right? There's a point here, there's a point here, there's a point here, here, all over this triangle. They all go through the same transformation. This question is really asking you, yes, Kaylee, you are right. It's really just asking you, what's the rule for the transformation? Elena, you are also right. So what is the rule? Oh, and Pia as well. What is the rule for this transformation? Remember that rule applies to every single point on that triangle. The more points, the more accurate the shape or the line, and so on and so forth. So, looks like we're getting it right. All right, so that means we're going to be doing our x comma y. Right, this is the setup for my rule. 5 units to the left, is that plus or minus?
Minus, sorry.
Minus 5. And y up is plus 3. So D is the one that matches that answer. So again, this question, I like it because it's kind of misleading, because when you look at your triangle originally, and you're going to see it when I give you guys the study guide, when you look at the triangle originally, you don't see point D. I made up where point D prime was. I just threw it on there. You don't see that point. You just see the main triangle, but it tells you that point is on this triangle. So it's just another way that they ask you, what is the notation for the rule for the transformation? Okay. Any questions on this one? All right, I'm moving on. We're making great time because yesterday we didn't quite get very far, and I got to number 11 in second period, and there's only 12. So we're making good time. Now, we have here, no, this one. All right, rectangle ABCD is graphed on a coordinate plane with these vertices, right? These are my points right here. It is reflected over the x-axis and then translated 4 units right. So 1, 2, 3, I'll do a different. 1, 2, 3, 4. 1, 2, 3, 4. Ta-da. I don't know why it jumped all the way over there, but whatever. This is my new rectangle. Now, what are the coordinates of D? Elena, you are right again. So think it through. Remember the reflection and then the slide or the translation.
Wait, for which
For
do you
my
mean-
final one, this one.
Oh yeah, okay. Yeah.
The final one.
Yeah.
Yeah, the other ones were just the dots. I did just the dots so that you could see it was the in between our final spot. All right, so my first step to do is to actually label, right? I didn't label the letters for a reason. This is C, this is D, this is A, and this is B. So when I just slide them over, D, C, B, A, prime, all of them with prime, D prime. So this point is at -1, comma, -1. Yes?
Yay, okay. Yeah.
So when you actually do your test, because you can't write on it, I don't think there's like a tool that will let you write on their graphs when they give you the graphs themselves. I'm not 100% sure. I have not taken one of these tests before, so I'm not sure if it's only for like certain problems that they give you the drawing tool. But if they don't, you are going to be able to have scrap paper. So when you do the scrap paper, just do an ugly little graph. Don't try to spend 10 minutes trying to make it neat and use a ruler and all that stuff. Don't do that. Just get it general, put your points. It might not be pretty. We've seen all of my graphs and they are not pretty, but I can get the right answer, even if they're not good, okay? So number 10, if point A is rotated 90 degrees counterclockwise, what is the new point? Would it, Kaylee? If it's going 90 degrees counterclockwise?
I mean, like, wait. Oh,
So put your answer. Close, Kaylee.
I don't know what I'm supposed to do. So
No, you're very close. You're just off by one thing.
Oh. I didn't mean 11. Take out a 1 from the answer.
So, Anicia, Daly, you are both correct. Kaylee, not quite. No, even without the extra one, it's still not. Think about it. Think about it. Yes, Jordan, you are right as well. So this one, now on the actual study guide, you're going to see it actually gives you a bunch of points, and actually the multiple choice options are actual graphs. But I wasn't going to be doing that because that would have taken me way too long and they would have been all over the place. So for this one, you need to rely on remembering the rule that when it goes 90 degrees counterclockwise, you end up with negative y comma x. Let me see. Okay, it is filling it. It's just slow. So negative y comma x. So if my point is 0 comma 2, and I'm going to do the negative y comma x, it now becomes, first I'm going to swap my letter, or rather my numbers, and then I'm going to put that negative in. So negative 2 comma 0. Do we see why, Kaylee?
Yeah.
Why did you say it like that? Do we understand? I want to know that we understand. I didn't mind the delay last class. I wasn't saying it like, oh, that darn Kaylee. I wasn't saying it like that. I'm saying it's fine. I don't have a problem. This is the time to ask me the questions. Don't ask me questions the day before the EOC or the day before your test. Now is the time for asking every single question you have. Okay? So we get this one. I think it would have been better to see the visualization, but like I said, it's one, I want to make sure that we know what we're doing without having multiple choice. And two, I didn't want to draw all those coordinate planes. So that's partially on me, but you can still do it as long as you remember the rules. Okay. Now, does Alexa see this triangle? This was,
It hurts.
Why does it hurt? It looks good.
Oh, it's supposed to be slanted? Oh, you did great, Miss Perdomo.
she's saying it's not good.
No,
No,
she's saying you
I'm
did
joking.
great.
It looks amazing.
Looks
The
good.
Dropbox. What about the Dropbox? Am I supposed to? Didn't I show you guys last time the Dropbox?
Yeah.
Or you have homework due for me today. That's what we're saying, right? I'll send the Dropbox link later. Through Remind at around 4:30, like I always do. Okay. All right. So next one. What transformation shows that triangle ABC? So triangle ABC is similar to triangle. Now, if I remember correctly, this is the similar symbol, right? Congruent is with the equal sign. Jordan, you're answering these questions ahead. You are correct. But there's one more thing I need to talk about afterwards. So the transformation is correct, but then I'll explain afterwards.
Wait. Sorry, couldn't hear what you said.
Whoa.
Which one's similar and which one's similar and which one's congruent?
So similar and congruent has the equal sign.
Okay, thank you.
So which transformation shows that they are similar? So go ahead and write it in the chat. We already kind of talked about this in the other problem, so we should already kind of remember. So just name the transformation. Remember, there's 4 of them. Translation, dilation, rotation, and reflection. What? Kayla, that's not the question.
Wait, what? I heard you say, wait.
What's the transformation that proves that they are similar?
Pia. No, I'm joking. I heard you say that what's similar between them.
No, that's not what I meant. I think you were confusing when I was talking about the similar thing. I don't know. I'm asking what do you have to do to make them similar?
Oh.
Yes, Kaylee. What's the other name that the book uses?
Oh.
Yes. That's the transformation I'm looking for.
How do you know that you're going from ABC to DBE? Or is it just like
I said so?
Oh, you said so? Okay.
No, because
And then you are correct. You gotta forget the first A. And then you're good. I'm a terrible speller as well, don't worry. That's why I teach math. So there's only one transformation that gives me shapes, that when the original one does this transformation, the result is similar, not congruent shapes, and that is a dilation. Now, in the question, you have the 4 options. 2 of them are rigid motion. So automatically you can eliminate those 2. The one you're looking for has to have the word dilation. Okay. Now, Jordan, how did you get by a scale factor of 2? I'm curious.
Okay, Jordan's here at the interview.
Yeah, so the vertical line AB, or I guess line AB and line DB, kind of counted line DB and then counted line AB.
Oh, okay.
DB by DB.
Then I'm very impressed with you and myself because the actual answer is a scale factor by 2. I didn't know you would be able to tell from my drawing. So it is a scale factor of 2. Where we are right now, the scale factor doesn't matter too much because of my 2 dilation options that I have in the multiple choice. Both of them say by a scale factor of 2. The thing that's different between them, so dilation by 2, the thing that's different is one is centered at the origin and the other one is centered around point B. Okay, so the way you want to look at this is if your triangle shrunk, it would have been, and it was towards the origin, it would have been somewhere more around here. Okay, but it shrunk pushing towards.
Wait, what
B.
did you just say?
What did I just say?
Why about it being in the middle? Also, how do you know you're going from one to the other? Would it be first in the question?
Like, how do I know I'm going from one triangle to the other?
Like you said yourself that ABC is going to DBE, but in a question, how would we know? Also, what was that thing about the middle?
So it doesn't, okay. I'm doing it because I think this is the easiest way to explain it. If I'm shrinking it down, if my larger one is the one to squish, but I could also say the same thing about it going outwards. The point is that my triangle doesn't go towards or around the middle part, which is my origin, right? If I was shrinking in the middle, I would be going towards the middle. If I was expanding to the outside, I would be more even. Okay. This isn't that. It's all around point B. It's all around this point here going outwards or going inwards. Now, they'll tell you, not in this example, but in other ones, they will say, they might call it the same triangle, and then they give you, triangle ABC is similar to triangle A prime, B prime, C prime. Then you would know which one is which, right? Your A prime,
Okay, yeah.
the translation, so on and so forth.
Okay.
Oh my gosh. Both periods ran out of time before number 12.
Bye, thank you.
All right, well, I'll see you guys tomorrow.
See you tomorrow. Bye, thank you.
Bye. I will send the Dropbox link to you all as well.